Welcome to the video on writing formulas and names for transition metals. Okay, the difference between transition metals and what you did in class, which is regular ionic compounds, is that now we're using a metal that is not from the representative elements, and therefore we don't have a charge for it. So for example, in class, we were using metals from the alkali metal, the alkali earth metal, or this column right here, because we knew that these guys were +1, this one's +2, and this one's +3. Now we're going to be using metals coming from the transition metals or the intertransition metals. And except for silver, cadmium, and zinc, you don't know what these charges are. That means I have to tell you the charges. And as I said in chapter 4, I'm going to tell you the charges using a Roman numeral. So you're going to see something like this, with the name and then the Roman numeral right after it. The anion is still going to just be from the periodic table. We have charges for every column of the anions. So let's try this example. Americum 1 plus phosphorus. So that means that we need to find the symbol, again, the symbol for americum is Am. Symbol for phosphorus is P. Americum is the metal, it's the cation, so it goes first. Phosphorus is the anion, so it goes second. Now, instead of looking at the periodic table to find what the charge is going to be, I'm just going to write the Roman numerals. It's +1. Roman numerals are always positive. Phosphorus I'm going to get from the periodic table, and that's -3. So, what's the lowest common multiple from 1 and -3? 3. In order to get this to be 3, I need to multiply by 3. In order to get this to be 3, I need to multiply by 1. So this is +3, -3, so it equals 0. And that's our goal, to get the whole thing equal to 0. Now these are our subscripts. So our final answer is AM3P. So the rest of it is just like what we were doing in class. The only difference is where does this number come from? Now let's talk about writing the names for them. The names are a little bit more complicated because we have to get the Roman numeral. The name for the cation is going to come from the periodic table, whatever the periodic table says. And then we have to put a Roman numeral after the cation, and we'll talk about how to do that in a second. The anion, the name is going to come from the periodic table, but just like those ions, those anion ions, we have to change the ending to I. So let's say we have this, RHBr3. So we look on the periodic table and we find RH, and its name is rhodium. And then Br is bromine. But I have to change the ending of this to I. So the E becomes I. I'm sorry, it doesn't have to be that. Now, we need a Roman numeral here to tell us the charge for rhodium. We're like, well, how do I know what the charge for rhodium is? We can figure that out from the formula. We know that bromine is -1. And so this whole thing is, there's 3 -1s, and this part is -3. We also know this whole thing has to cancel out to 0. So it becomes basically now x minus 3 equals 0. What is x? Well, there's only one of these, so it's only 1x. And so x is +3. So it's rhodium 3 bromide. Alright, let's do something a little bit more complicated. Let's say that there was a substrate there. So let's say that we wanted MO2, and I'm sorry, MO3 and 2. Okay, so MO is molybdenum. N is nitrogen. But then I have to change the ending to "ide," so we go nitride. Nitrogen has a -3 charge, and there's 2 of them, so that makes this whole side -6. And then it's 3 times the charge, so 3x minus 6 equals 0. 3x minus 6 equals 0, so 3x equals +6, x equals 2. So this molybdenum 2 nitro. Very simple little algebra problem there. And where x stands for our charge. And this time we had 3 of them, so we had to divide by 6. And that's how you write formulas and names for transition metal compounds. Thank you.